Hey, what's going on, guys? We have this question right here. It's asking, use the definition of derivative to find the derivative of f of x minus secx plus 2. So let's see how we can do this. First of all, we have to write down our definition of derivative. It's going to be f prime x is equal to limit h approaches 0, limit, sorry, h approaches 0, then we have f of x plus h minus f of x over h. Then limit h approaches 0. Now I have to substitute this x plus h for this one, so it's going to be minus sec x plus h plus 2 minus sec x plus 2 over h. So now let's simplify this one. So limit h approaches 0. So I can write this one as 1 over cos x plus h. So it's going to be 1 over minus cos x plus h plus 2. This minus, same thing right here, can be written as minus 1. Oh, I can take this out of the bracket, so it's going to be 1 over cos x minus 2 over h. Okay, 2 cancels each other. Then we have this thing remaining, so it's going to be limit h approaches 0. Now what I can do is I can take the common denominator of both of them. So it's going to be minus cos x plus h over, it's going to be cross multiplication, it's going to be cos x minus cos x plus h. So now what I can do is I can limit h approaches 0. So I can expand this one. It's going to be cos x minus, this is going to become cos x cos h minus sin x sin h, then over minus cos x plus h. Now I continue this side, so it's going to become limit h approaches 0 cos x minus cos x cos h minus, it's going to become plus, I am taking out of the bracket, so it's going to be plus sin x sin h over minus cos x cos x plus h. Now what I can do is to get rid of this negative sign, I can divide everything by negative, so it's going to be limit h approaches 0 minus cos x plus cos x plus h cos x cos h minus sin x sin h over cos x cos x plus h. Now I have to rearrange this one a little bit. I'll show you why did I do that. So limit h approaches 0, so cos x cos h minus cos x minus sin x sin h over cos x, and we have to carry this h too, so this h is going to be in the bottom all the way right here, cos x plus h. Then what I can do is I can take the cos x command, limit h approaches 0. If I take the cos x command, I will get cos h minus 1 minus sin x sin h over cos x cos x plus h or times h. Now I show you the rule. So there are two common rules we have to remember before we go further ahead. The first rule is when limit x approaches 0, if we have cos x minus 1 over x which is equal to 0, that's one rule. And another rule we have to remember that when limit x approaches 0, sin x over x equal to 1. So this is another rule. So this is why I rearrange this equation, because when I bring this one into, we are almost getting that format. So the only thing we have to get is we have to get the h below this to make this one equal to 0. So let's see how we can bring it. So limit h approaches 0. So to get the h on in the bottom, I take the cos x 1 over cos x plus h common to everything. So if I do that, I will get 1 over cos x plus h, and I write the other thing in a bracket. So limit h approaches 0, cos x cos h minus 1 over h minus uh, limit h approaches 0 sin x sin h over h. I continue here. So limit h approaches 0, this is going to be 1 over cos x plus h. Then maybe I can now substitute the 0, maybe one more step. Okay, one more step. Limit h approaches 0. So before I write that one, I bring this cos x in front of the limit, because we are only dealing with the h, so therefore we don't need this. Let's bring this one. So it's going to be cos x limit h approaches 0. It's going to be cos h minus 1 over h, then minus limit. Also here also I can do the same thing. I can bring the sign to the front, so it's going to be sin x limit h approaches 0 is going to be sin h over h. Now I can substitute everything. So if I substitute 0 here, this is going to become 1 over cos square x. So this whole thing is going to be just become 0. Then here we are going to get minus sin x times this whole thing is 1. So we have left with minus sin x over cos square x. We can also write this one as minus tan x sec x. So this is my final answer, and this is how we derive this answer. I hope you guys liked this video. See you next time.